Hello everyone, this is Athreya and welcome to our channel CodeChef. Today we're going to be solving the problem ADASTAIR staircase with the code ADASTAIR, and the difficulty level of this problem is cakewalk. Let's get started. Here is written that there is a big staircase numbered from 1 to n in Chefland, and let's denote the height of the top of the step I by hi. Chef is currently at the staircase at height 0 and she wants to reach the top of the staircase. However, she can jump from height hi to the top of a step at height hf. So from hi she can jump to hf only if the difference of heights is less than or equal to k. To help Ada, we are going to construct some intermediate steps. Each of them may be constructed between any two steps or before the first step and have any height. What is the minimum number of steps that have to be constructed so that Ada can reach to the top? Let's look at the sample case. Here, one thing to note is the input that we are given will always be strictly ascending. This is one thing to note. It will always be strictly ascending here, the input. So here the input is basically first, one thing that you should not miss out is, can Ada reach from step 0 to step with height 2 basically first? Because k is 3, this is a direct jump. Because she can jump as long as the difference of heights is less than or equal to k. 2 minus 0 is less than or equal to 3. Hence, this is a direct jump. From step at height 2, she can jump to step at height 4 directly. Why? Because the difference between these two heights are 2. 2 is less than or equal to 3, hence this is a direct jump. However, she cannot jump from 4 to 8 directly because 8 minus 4 equal to 4, which is not less than or equal to 3. Hence, we need to construct an intermediate step. Because we need to minimize the number, of intermediate steps constructed, what if we construct the step at the highest height possible that she can jump? From step 4, if we construct a step at height 7, which is the maximum height, because this k is 3 for her. From 4, she can jump if there is a stair at height 7, because 4 plus 3, the maximum is 7. So we construct one intermediate step at height 7. So this is the constructed. The steps that we construct, I have just done this, hash pattern here. So this is the step that we construct. From 4, she jumps onto our intermediate step 7. From 7, she can directly jump onto the next step, which is 8. She can directly jump because 8 minus 7 equal to 1 and 1 is less than or equal to 3. Direct jump. From 8, she cannot jump to 16 directly because the difference is 8, much more than 3. So what we do is, we construct another intermediate step because 8 plus 3 equal to 11. We construct one intermediate step and we check. From 11, can she reach 16? No, because difference is 5, still more than 3. So from 11, we construct another intermediate step at 14. So from 8, we have constructed two intermediate steps in order for her to reach 16. So you will jump from 8 to 11, and this is a valid direct jump because 11 minus 8 is less than or equal to 3. From 11, she will jump to 13, which is a direct jump because 11 to 14, 14 minus 11 is 3 and 3 is less than or equal to 3. So from 8 to 11 it's a direct jump, from 11 to 14 it's a direct jump. Now from 14 to 16 it is again a direct jump because difference is less than or equal to 3. So we have constructed 3 steps. We have constructed this step and this step. The output is 3. We have constructed a minimum number of steps because at each part we have constructed the highest height. We have now constructed a step of height 10 because that will be useless because you have 11 here. She can jump from 8 to 11. So while you construct 10 here and increase the number of steps, we need to decrease the number of steps, minimum number of intermediate steps. So from 8, what is the maximum step that she can reach in one jump? So from 8, she can jump to 8 plus 3, the maximum, 11. From 11, she can jump to up to height 11 plus 3, 14. From 14, she can jump up to height 14 plus 3, which is 17. And 16 is anyway less than 17. So it's a direct jump here. So 3 steps constructed. So let's look at the approach. One observation we need to note is jumping from one step to another only depends on the difference between their heights and k. So let's say that we are at step x. Since we are at step x, a direct jump involves if the next value is between x and x comma k. For example, if k is 3 and we are currently at height 2 and we want to jump to anything here, which will be a direct jump. As long as the next value is between 2 comma 2 plus 3, both inclusive, as long as the next value is between 2 comma 5, it will be over in a direct jump. She can directly jump here. Because this difference, whatever you have in this range, its difference with 2 is nothing but less than or equal to k. Now let's look at another case. Let's look at, we are at now step 9. And we are now trying to reach 15 and our k value is, let's say, 4. So we first check the difference. This is our step where we are currently at. This is the step where we are trying to reach. We are trying to reach this step. 15 minus 9 is 6. So k is 4 here. Because k is 4 and the difference is 6, it cannot be over in one jump. Because our difference 15 minus 9 is not less than equal to k, which is 4. Now we need to construct intermediate steps. How will we decide the number of intermediate steps that we need to construct? So you can just say from 9 we can construct 13, and from 13 we can reach 15, because 9 plus 4 is 13, and once we construct this step at height 13, from 13 she can directly reach 15, because 13 and 15 the difference is less than equal to 4. But how will we directly programmatically find out that the number of steps to construct is 1? There are two cases we need to find out. This difference between the current and the next, basically difference is nothing but the where you are at and where you are trying to reach, right? That is a difference. So you can just write current minus next, or next minus current, whatever you want. Now there are two cases. If your difference mod k equal to 0, let's look at another case quickly, where your k is equal to 2 and the difference is same. So this thing is same. You're still trying to reach from 9 to 15. From 9 you're trying to reach 15, but your k is now 2 instead of 4. Because your k is 2, the difference mod k equal to 0 condition is satisfied. So you might say that, why are you even thinking about this condition? Can't you just stop there itself and say that difference by k number of steps you have to construct between two steps? No, because let's say here difference by k. What is difference by k in this case? Difference by k is 3. Are you going to say that from 9 to reach 15 you're going to construct 3 intermediate steps because difference by k equal to 3? No, because I can do it in 2. How 2? Because 9 plus 2 is 11, 11 plus 2 is 13, 13 plus 2 is 15. We only needed to construct 2 intermediate steps in order to reach from 9 to 15. Hence, if difference mod k equal to 0, construct difference by k minus 1 step. Why difference by k minus 1 step? Because 9 plus 2 is 11, 11 plus 2 is 13, and 13 plus 2 is 15. Because your difference mod k equal to 0, your third step will be the step you are trying to reach. Hence, you do difference by k minus 1. Because difference by k also counts this step, which we don't want to count. Hence, it is difference by k minus 1. Otherwise, if your difference mod k not equal to 0, like in this case here, you can just do number of steps equal to number of steps plus difference by k in the else condition. It's just difference by k. Because here difference was 6 and k is 4. 6 by 4 normal integer division is 1. I mean, it's 1.5, but then, normal C++ floor division, it's 1. So you can get away only by constructing one step. So we will process index by index, and we will check this difference. And this difference is less than equal to k. If this difference is less than equal to k, nothing. No steps need to be constructed. It's a direct jump. However, if this difference is greater than k, then there will be two cases that entail. This difference is greater than k. In order to reach this from here, you need to do, if difference mod k equal to 0, do difference by k minus 1 steps. Difference by k minus 1 steps. Otherwise, construct difference by k steps. Once you do this, you can jump from here to here. Similarly, process every index. A very important scenario is you need to process before this also. You need to process this also. The height before the starting index. Let's say your k was 4 and your starting index is 5. It means that from 0, you cannot even jump to your starting index because your k is 4 and your difference is 5. You need an intermediate step here so that you can jump onto this intermediate step of height 4, and then from there you jump to 5. So that this will mess up your answer if you do not consider a condition where your starting is 0 and your first index is 5. For example, you need to check. In this case, we are given a very easy case where it's 2, 4, 8, 16. This was 2 and k is 3. So from 0, you can directly jump onto 2. No problem, because the difference is less than equal to k. However, what if you had k as 3 and you had a different input? Let's say your input was 4, 8, 15 and 23. Let's say this was your input. From 0, because normally you figure out all the approach and everything and you just start processing this like this. You will say 8 minus 4 is 4. So 4 by 3. So you need to construct one step here of height 7. So you jump from here, jump here, you process everything. Very, very nice, very cool. But because you did not process this initial condition where you need to jump onto 4 from 0, your whole answer will become wrong. Because you cannot jump onto 0 from 0 to 4 directly because your k is 3. You need to construct one step of height 3, jump onto here. From here, you need to jump onto 4. So your answer will differ by 1 if you do not consider this condition. This is very important. Many people miss this. Hello everyone, let's look at the code for the approach that we have just discussed. We'll first look at the C++ code. Here, after inputting the heights of the stairs, we then initialize a variable number of steps equal to 0. And this is very important. We have heights of 0 equal to 0. If you miss this out, like I mentioned previously, it's a common mistake that many people do. The code will not work. So heights of 0 equal to 0. Then we process from I equal to 1 till n. We have followed one indexing here from 1 till n, and we perform the difference. Initially, I is equal to 1, and it would be heights of I minus heights of I minus 1. That is why this condition is necessary, where you have from 0 you're going to jump to the first index. So we have heights of I minus heights of I minus 1. You do not need an absolute function because we are guaranteed that the input that we have will be strictly increasing. So we know that heights of I will always be greater strictly than heights of I minus 1. Now, after computing the difference, we check the condition that we discussed. If the difference is greater than k, if difference is greater than k, only then we have this. If difference is less than or equal to k, no jumps. It's a direct jump to there. No intermediate steps to be constructed. Using just one direct jump, you can reach there if difference less than or equal to k. However, if difference is greater than k, we check if difference mod k equal to 0. If difference mod k equal to 0, we add number of steps equal to number of steps plus difference by k minus 1. Otherwise, number of steps is nothing but difference by k. If difference mod k not equal to 0, you just have difference by k. If difference mod k equal to 0, you will have difference by k minus 1. The reason for which we discussed here. Then finally, after processing every index from 1 to n, we just output the number of steps at the end. Similarly, let's look at the Python code. In the Python code, what we do is we take n and k as input, and then we take heights as input. We have the length here, and we have a previous variable here, just switching up a little bit in the implementation. And we have number of steps is 0. Now, instead of using a separate, heights of 0 equal to 0, we have a separate variable previous that keeps track of the previous. So we are trying to jump from the previous to the next. So for I in range length, here we are following 0 indexing. In this 0 indexing, what we do is difference equal to heights of I minus previous. We are trying to jump from previous till heights of I. So we compute the difference. Now difference mod k equal to 0, number of steps is difference by k minus 1. Here we use integer or floor division, hence a double slash. Similarly, otherwise, if difference mod k not equal to 0, we just have plus equal to difference by k. Now we update previous. Since you have jumped from previous till heights of I, your heights of I becomes your new previous, and from there you again process every index. And at the end print the number of steps. Hope this is also clear. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.